Have you ever wondered how everything around us, from the smallest atom to the vast cosmos, came into existence? The answer to this colossal question takes us back to an event known as the Big Bang. Imagine a moment approximately 13.8 billion years ago, when all of the universe's matter and energy were compressed into an extraordinarily hot, dense point or singularity. This singularity, smaller than a pinhead, contained the seeds of everything that now exists. Then, in an instant, this singularity exploded. This was not an explosion in the conventional sense, hurling matter outward into pre-existing space. Instead, it was an explosion of space itself, where space and time began to expand everywhere and everywhen simultaneously. This is the Big Bang. In the first fractions of a second after the Big Bang, the universe underwent a rapid inflation, expanding faster than the speed of light. The young cosmos was a hot, dense soup of particles, rapidly cooling as it expanded. For the universe's first 3 minutes, it was hot enough for nuclear fusion to occur. During this period, known as the epoch of nucleosynthesis, the first atomic nuclei formed. Protons and neutrons combined to form hydrogen and helium, the two lightest elements. As the universe continued to cool and expand, atoms began to form. These atoms clumped together under the influence of gravity, forming stars and galaxies. This process took hundreds of millions of years, marking the birth of the first stars around 300 million years after the Big Bang. Fast forward to around 9 billion years after the Big Bang, and something incredible happened. Our own solar system, including the Earth, was born. Today, the universe continues to expand. Galaxies move away from each other, and the space between them grows. This expansion, first proposed by Edwin Hubble in the 20th century, is a direct consequence of the Big Bang. To summarize, the Big Bang is not just an event but a theory that describes the birth and evolution of the universe. It started from a singularity, exploded and expanded faster than light, cooled down to form atomic nuclei, which later formed atoms, stars, galaxies, and eventually our own solar system. The Big Bang theory is not just a story. It's a scientific explanation built on observations of the cosmic microwave background radiation, the abundance of light elements, and the redshift of distant galaxies. These observations provide a snapshot of the universe at different times, allowing scientists to reconstruct its history. So, the next time you gaze at the night sky, remember, you're not just looking at stars, you're peering into the history of the universe, back to the explosive moment of creation we call the Big Bang. A remarkable narrative of cosmic evolution written in the language of science.